Okay, so let's say we want to find the volume of the region. Okay? Let's say we wanted to find the volume of the region So, if I plug xy as 0 into this thing, what I'm going to get? I'm going to get z, which is going to equal 1, which would be right there. Okay, I'm making bigger on purpose. Okay. Now, let's say we plug z, which equals 0 into there. What would we get? Well, we would get x squared plus y squared equals 1. That. That's a circle. This type of shape we're looking at. All right. So once again, when doing this problem, you want to think, well, I have to go 3 dimensions, then I have to go 2 dimensions, and then I have to go 1 dimension. Okay. So when I'm talking about my 3-dimensional one, okay, I'm going to do dz first because we already have z as a function of x and y. Okay. Could do one of the other regions first. It would just make the problem look nastier. So I'm going to think of this as a volume. So in a 3-dimensional sense, I'm going from the plane z which equals 0 up to this surface z which equals 1 minus x squared minus y squared. So that's my dz direction. Okay, so dz, okay, for this guy, z would equal 0, and it would go up to z which equals 1 minus x squared minus y squared. Okay, so I have a z as a function of x and y. Okay, now we have to consider what is the next direction I go. And it's not unique if you pick, you can pick dy or dx. Let's just say, let's pick dy. Okay? And so within 3 dimensions, you're going up from a plane to a surface. Now, when you're talking about 2 dimensions, you already did z. Okay? So let's say we wanted to do y as a function of x. So that means I would be in the xy plane. So let z equal 0. Okay? So if I said z is 0, what am I going to get? I'm going to get the circle So let's say I wanted to do this in the y direction. Actually, I'll change it around. I'll do it in the x direction as well. But now we're talking about a two-dimensional quantity, okay? So in this two-dimensional quantity, if I'm gonna do this as a dy, I need y as a function of x, okay? So my dy would go from y would equal negative square root of 1 minus x squared to, so it's going from the bottom of the circle to the top of the circle. So that would be y, which equals positive square root of 1 minus x squared. Okay? And now whenever I'm talking about my dx, I'm talking about a one-dimensional quantity. Now, if I imagine the dx as this, it would just be going, oh, sorry, move off the screen. That. So for dx, x would equal negative 1, and it would just go positive 1, okay? So, the triple integral dv would equal the integral from negative 1 to 1, the integral from negative square root of 1 minus x squared to positive square root of 1 minus x squared, and the integral from 0 to 1 minus x squared minus y squared. And we're just calculating the volume, so we don't, it's not over a vector field or anything. So this would be dz y dx. Okay, so that's how we would formulate that. And you know, if you think about it, if you wanted to do this one right here in terms of x in this direction, what would really change? This would be negative square root of 1 minus y squared. That would be positive square root of 1 minus y squared. And this thing would still be negative 1 to 1. So, you can go ahead and write that. But that's what you want to think about whenever you're doing triple integrals. Is first, I have to think about a three-dimensional one that might go from one surface to another surface, or from a plane to a surface, and then a two-dimensional one that is going to go from possibly one line to another line, and then a one-dimensional one, which is just going to go from, well, a constant to a constant. Okay?